Welcome back everyone to part 5 of this text generation series of lectures. In part or step number 5, we're going to be showing you and talking about training the model. We're going to quickly show you an example of how to train the model, but more importantly, since this model has over 3 million parameters and it essentially requires a GPU to train in a reasonable amount of time, we'll show you how to load our provided saved model file. What we're also going to do is just to make sure everything is running correctly, we'll run the model without it being trained, and we should expect just to see random characters show up. Let's head to the notebook and see this all in action. All right, so here I am at my notebook, and the main thing to notice right now is when we call our model summary in the previous set of lectures, we're dealing with over 3 million parameters. And because this is a recurrent neural network with over 3 million parameters, we really need a GPU to train this. So in case you don't have a GPU locally, especially since you require an NVIDIA card and a correct installation of CUDA, what I'd highly recommend is uploading this notebook to Google Colab. So I'm filming this right now on a laptop that doesn't actually have a GPU. So I'm going to come to Google Colab and quickly show you how you could upload this notebook along with the text dataset. So just Google search Google Colab, click on collab.research.google.com, open it up, and it will come with a new notebook. And then what we can do here is we can say File, Upload a Notebook. And you may need to sign into Google. That's okay. Go ahead and just sign in with your Google account. And then once you're signed in, you should be able to then say File, Upload Notebook, and then choose a file. I'm going to choose the untitled notebook that we've been working with. So go ahead and click Choose File, and then underneath right here, NLP and text data, I have my untitled notebook. If you want, you can also upload our actual notebook that we provide for you, but we're going to continue with the lecture we've been leaving off. So I have this entitled one. I'll go ahead and open it up and upload it. I'm going to fast forward so that's done. Okay, and we can see the untitled notebook being uploaded. And here we can see everything that we've been doing so far. The last thing I need to upload is the actual text dataset, since Shakespeare.txt isn't actually part of Google Colab. So we're going to expand on this right here and then click on Files. And in order to upload files, you need to connect to a runtime. So in case it hasn't already, look at the top right and make sure it's connected to a runtime. And then once that's done, you can hit upload here and then upload this Shakespeare text file. So it's just called Shakespeare. Do not upload this .h5. That's actually the model file that we're using. If you want, you can upload it as well in case you want to load the model. But if you're strictly just going to train, Shakespeare is the actual text file, Shakespeare gen.h5, that's the model file. I'll go ahead and upload both of them since we will use both of them eventually. So go ahead and open that, and then it'll remind you that they'll get deleted once this runtime's over. That's okay. And then we can see here they're uploading. I'm going to go ahead and fast forward in time until that's all done uploading. All right, now that those files are uploaded, I have the text as well as the trained model, which we're going to load up later on. We'll go ahead and close this, and what we'll do is to make sure we're using TensorFlow 2. Later on, this is going to be the default, but let me zoom in here so you can see these commands clearly. What we're going to do here is we're going to say %, TensorFlow version, space 2.x. And then once we do that, we're just going to hit runtime, run all. So that will set TensorFlow as version 2.0. And then once that's ready to go, it'll read in the file and do all the encoding and decoding commands that we did before. So you should be able to then scroll down all the way to the bottom of this notebook if you've been following along, and you'll see the model summary pop up. So again, we're dealing with more than 3 million parameters, which definitely means we need GPU. So make sure you confirm that you're running on GPU as shown in the original setup lecture for Google Colab. What we're going to do now is we'll go ahead and make sure everything is okay before we actually train our model by saying, by actually running an input batch. So we'll say for input underscore example underscore batch, comma, target example batch in dataset, and then we're going to take one from this dataset. And I'm going to zoom out just one level so these icons don't take up too much. So what we're going to do is we're going to run through an example batch, just one simple batch, and then we're going to pass it into our model. So that means the example batch predictions is going to be equal to the model, and this is where we're going to input the example batch. So the input example batch. Recall that the input example batch, that is the original sequence. The target example batch is that sequence shifted one character forward. So right now, without even training the model, I'm passing in an example input batch, seeing what the model predicts. If the initializations are truly random, then it should just be a bunch of random characters that it predicts should be the sequence one timestamp into the future. So we go ahead and run that. And then once that is finished running, what I'm going to do is I'm just going to check what those example batch predictions actually look like. So we'll say example batch predictions. Let's first check the shape of this. So the shape is 128 by 120 by 84. And this is the batch size. So 128 is the batch size that we chose earlier. So the 120 is the sequence length of the batch, 120 characters. And then 84 is the vocab size. So then let's go ahead and grab the very first of these predictions by saying index 0. And you'll notice it's essentially a bunch of probabilities. So these are the probabilities that it assumes for each concurrent character. So what we can do here is the following. We can say, using some TensorFlow commands, tf.random.categorical, and it takes in those logits, which is essentially just a term for the log odds or logarithmic probability here. And then we're going to say just number of samples to grab is 1. So we'll just do that because I just want a single sample. So we'll say sampled indices. And it's going to grab from that probability distribution. And then we'll say, let me make a couple more cells here. Underneath here, we'll say sampled indices. And if we check out what that looks like, it's essentially the actual indices of the characters it thinks it should be predicting. And in order to pass in this sort of shaped array into our index to character sequence, what we're going to do here is the following. We'll say sample indices is then equal to tf.squeeze. And then we'll pass in sample indices. Axis is equal to -1. NumPy, and that essentially reshapes it. So now it's going to look like this, which is exactly the format we wanted in. So I can pass it into this index to character array. So go ahead and pass it to the index to character array. And running that gets you a bunch of random characters. So this is essentially its prediction. And it's just a bunch of random characters, which makes sense because the model hasn't been trained at all. So if you wanted to train the model, what you would do is simply say the following. You would choose some number of epochs, and I would highly recommend at least 30 epochs to get realistic results on this particular model. So you would specify some number of epochs, such as 30, and then simply say model.fit to the dataset object we made earlier, where epochs is equal to the number of epochs specified. Run that, and then it will begin fitting your model. So in our case, I'm going to go ahead and interrupt this training because this is going to take a really long time to run. In my experience, it took about somewhere between 1 to 2 minutes per epoch. So this is running a little bit faster right now, but it will take some time, especially for such a large model. So what I'm going to do here is simply say runtime interrupt execution. So I'll actually interrupt the training of this. And then you'll see that keyboard interrupt pop up. That's okay. If you want, you can kind of sit around and wait for it to train if you're really interested in that. But what we're going to do is we're actually going to load up the model. So we can do that by saying from tensorflow.keras.models import load model. And in order to load the model, make sure you uploaded already this shakespearegen.h5 file. So that's our model. So in part 6, what we're going to do is we'll finish off this lecture by actually loading up the model. We're going to do it in a specific way just to load the model weights first and then build it to a different batch shape. So we'll show that all in the very next lecture. So coming up next, we'll show you how to load the model in a very specific manner. I'll see you there.